So how can we describe an ideal operational amplifier in Symbulator? First, we give it a name. It has to start with the letter O. Then the positive node, then the negative node, and then the output node. I like to use the name O for the node that I put in the output, but that depends on the circuit. Separated by commas. Symbulator provides us with two answers associated with an ideal op-amp. The first is the power consumed by the op-amp, stored in a variable P and the name of the op-amp. The second is the current flowing out of the output node, that's stored in a variable I and the name of the op-amp. So consider this circuit. Let's see how we could describe it. I have named the nodes for you. 0, 5, 6, 3, 2, 4. There's no 1, there's no 2. The reason there's no 1 and there's no 2 is because our sources are called V1 and V2. And if we want to use those as values for the sources, it would be confusing to have a node name, for example, 1, because then V1, does it refer to the value in the source? Does it refer to the voltage? So we have to be careful not to have a node 1 if we are going to use V1 as a constant. We describe the resistor. We have R1 between 5 and 0, value of R1, R2 between 5 and A. The reason I'm calling this A is because the circuit has a VA there. Therefore, by calling that node A, VA will be the voltage in that node. Value of R2. We have a resistor R3 between A and 6, value of R3. And we have a resistor R4 between 6 and O, value of R4. The reason I call that node O is because then the variable VO will be the voltage in that node and it will match the schematic. We have an independent source between 3 and 0 with a value of V1. Here you can see why I didn't have a node 1. If I had, then Symbulator would think it's a dependent source that is controlled by the voltage in this node. But that's not what I mean. I mean a constant, unknown constant called V1. So I have to make sure that there's no node 1. Same for the second voltage source, E2 between 4 and 0, V2. Now, if I was desperate to use a node 1, then I would just call this source something else, something like VS1 or whatever. Just you cannot have one single variable mean two things in Symbulator or anywhere for that sense. Now we come to describing the ideal operational amplifiers. The first one in the left I have called O1. Positive node is 3, negative node is 5, output node is A. For the second one, O2, positive node is 4, negative node is 6, output node is O. So our description is complete. So let's simulate this circuit in DC and find the voltage in node O. Here is our circuit description. We copy it, we're going to paste it. Between the quotation marks, store it in a variable, and then we run the DC simulation. Speeding up the emulator so that it's faster. When we get the answers, we ask for VO, and you will get an expression which should match the expression given by the book. Now, since the calculator groups it in a different way, we can ask it to expand that expression, VO, in terms of one of our variables, and the answer we get is, it's easy to see, it's the same as the book. The terms are, the first term here is the second in the book, but that doesn't matter, it's the same expression.